In this video, we're gonna learn how to evaluate certain expressions with inverse trigonometric functions for especially for uncommon values. For uncommon values, uncommon values. Earlier we learned like things like this. So earlier we learned how to evaluate. For example, what is cosine inverse sine uh, 2 pi over 3. So we learn about this one in the inverse trigonometric function video. So what we normally do is first we check whether this value is in the domain. Actually, in this problem, you can see that the two functions are different. Like one is cosine, one is sine. So in this case, like what we normally do, we evaluate the inside function first. So that means we simply repeat the cosine, the first outside function, and then we try to evaluate the inside function. And you can see that this angle is in the second quadrant. Since the angle is in the second quadrant, so this is 2 pi over 3, which is in the second quadrant. So we can look for the reference angle, and you can see that the reference angle is pi over 3. Um, and also using the ASTC, so we talked about those things earlier, ASTC, and you can see that this is in the second quadrant, and which is sine, so that means this is simply going to be sine the reference angle, pi over 3. That's we talked about these things earlier. Now we can evaluate a sine pi over 3. This is coming from the common table, and then you can see that this is simply cosine inverse. Sine pi over 3 is equals to square root 3 over 2. Now what we're going to do, we're going to find what is the cosine inverse square root 3 over 2, which is also a common value. That means for what angle you're going to get the cosine equals to square root 3 over 2. And then you know that that's going to happen for pi over 6. So this is pi over 6. So that means that's what you get for the first one. So let's look at another one, like something like this. Let's say we have sine cosine inverse 1/2. So this is the other type. So in the first one you have inverse of a trig function, then the second one is function of inverse trig function. So for the second one, we simply evaluate the inside. Again, you can see that the two functions are different. So you simply evaluate the inside function. So you can see they're asking what is the for what angle you get the cosine equal 1/2, and you know that that's the angle is pi over 6 is pi over 3. So the angle is pi over 3. Now what we're going to do, we can evaluate sine pi over 3. So sine pi over 3 means square root 3 over 2. So that's what you get as the answer. So that means if you know common values, you can simply evaluate them like this. So the problem is like this. Um, so what if what if you have these kind of problems. So let's say what is sine cosine inverse 1/3. If you have 1/2, you know what to do. But what are you gonna do for a problem like this? So so you know that so you should get a value, but what value you gonna get? So this is the kind of question we're gonna try in this one, and also the other type. For example, cosine inverse. Let's say sine pi over 5, something like that. And then you can see that so we try to find an angle. Let's say alpha, that satisfies this equation. So you can see that these values are not common. So 1/3 and pi over 5 are not common values in the tables. That means we need to use a different argument for these kind of problems. So first in this video we're going to consider the first type, and then we're going to consider the second type as a special problem. in a different video. So, so the problem here is because of those values are uncommon, so you can see that you cannot use the table. So that's the first problem. So cannot use the table, the common table, common value table. And then also for normally what we're going to do for this problem, we're going to use a substitution. So use a substitution. That's how you solve these kind of problems. You can, because we know that the cosine inverse 1/3 is an angle. So we're going to consider this angle is theta, and then we can use that idea to solve the problem. So let's look at several examples. So as the first example, we're going to solve this problem. So we can evaluate the first one, sine cosine inverse 1/3. So what we can do, and we know that the inverse functions are angles. So I'm going to consider this is simply theta. So we're going to consider the inside function as theta. So that's how we can start. So we can say let theta equal cosine inverse 1/3. And once you pick that, then you can see that taking the cosine, so this means that the cosine theta equal 1/3. So if you take the cosine of both sides, so you can see that you can write this one as cosine theta equal 1/3. So and then so what happened here is you can see since you pick the inside function theta, what you're looking for is simply sine theta. So you try to find what is sine theta. So what we're gonna do normally, we can use this cosine theta equal 1/3 to draw the triangle. So if you draw the triangle for this one, so let's draw a general triangle. Assuming this is in the first quadrant because these are positive. So this is the angle theta. So cosine means adjacent over hypotenuse, that means 1 and 3. So you can use those values using the cosine theta because cosine theta means adjacent over hypotenuse. So that's means adjacent become 1, hypotenuse become 3. Now what we can do, we can use the Pythagorean identity to find the other value. So you can see that y squared plus 1 squared equal 3 squared. So that means y squared equal 1 squared, 3 squared, those are 1 and 3, so you're going to get 8. That means y equals, since this is positive, you can say square root 8, which is 8 means 4 times 2, that means 2 square root 2. We get the positive value, so that means 2 square root 2. Because why we get the positive value, because it's in the first quadrant, so you can write it like that. So now what we can do, we use this triangle to find any ratio we want, but what we simply need is sine theta. We are looking for sine theta. So according to this triangle, sine theta means opposite over hypotenuse, that means 2 square root 2, that's opposite over hypotenuse means 3. So that's the value you get. So you can see that the problem is very simple. So what we did was we used some substitution. So the substitution help us solve the problem. So that's the starting point. So let's look at another problem. As the next problem, we're going to evaluate tan sine inverse negative 1/4. So this problem is also very similar to what we did. As we did before, we know that the inverse function is giving an angle, so we're going to call this is theta. So that means we're going to say let theta equal sine inverse negative 1/4. So this problem may be slightly different from the previous one because there's a negative sign here. Please note that, remember, when we have sine inverse, or in this case theta, is defined in the interval negative pi over 2 to pi over 2. So since this is negative and sine is an odd function, sine inverse also become an odd function. So that means, so theta is in the fourth quadrant. So you can see that. So you can say then theta is in quadrant 4. Quadrant 4. So that's what we notice, because the negative sign, it is in the fourth quadrant. So so that means taking sine, so you can write this one as sine theta equal negative 1/4. Now the question is, where are you going to put the negative sign? And you can see that you can write this one as negative 1/4. That means the opposite is negative 1, 4 is the hypotenuse. So we can draw the triangle in this case, but angle is in the fourth quadrant, so we're going to draw it like this. To the fourth quadrant, so we can write it like this. So that's where the angle is in. So this is the angle theta. So this is -1 because that's the opposite, and the 4 is the hypotenuse. That now what we can do, we're going to find the x value. So we can use the Pythagorean identity for that. So you can see that x squared plus -1 squared equal 4 squared. So in this case, x squared is going to be 15 because 4 squared is 16 and -1 squared is 1. So this says that since x is a positive value, x is a positive square root 15. So x equal a positive square root 15. Since we know all three values, we can find any angle. So that means our problem now simply becomes, once you take the sine inverse as -1 for this, simply becomes tan theta. So that's what we are looking for. So that means according to this triangle, tan theta is opposite over adjacent. So that means a -1 over a 15 square root. So you can simply write this one as -1 over 15 square root, or multiplying by square root 15. So you can say this is negative square root 15 over 15. So you can consider one of them as the answer. So that is how you can solve a problem like this. So what happened here, what we notice it, the angle is in the fourth quadrant. So let's look at the next problem. So as the next problem, we're going to do find the exact value of a cosecant cosine inverse -1/3. So as before, we're going to take the inside part as the angle theta. So we can see, and once you do that, you can see what we need is cosecant theta. That's what we're looking for, because if you say the inside part is theta, it's going to be cosecant theta. So the process is exactly the same as before. So we're going to say let theta equal cosine inverse -1/3. So you can see that the cosine negative means the so you can see that then cosine theta is -1/3. So once you take the cosine of both sides, you can say cosine theta equal -1/3. So and you can see that then cosine theta equal negative, and you can see the theta is in the second quadrant because it's a cosine negative. So if you consider the domain of the range of the cosine inverse function, theta has to be in the second quadrant, and theta is in quadrant 2, second quadrant. So and then we can draw the angle. So this is in the second quadrant, so you're gonna get something like that. So this is the angle theta. So what we do, we drop the perpendicular as we did before. So this is the cosine theta. So you can see cosine theta equal -1/3, and then you can see the so we can write this one as -1/3. So that means this is -1, and 3 means the hypotenuse, which is 3. So the adjacent of hypotenuse. So goal is to find the other side, and you can see the other side is 3 squared minus a -1 squared square root. So that means it is 3 square means 9 minus 8, so it's square root 8. Square root 8 means 2 square root 2. That's from the Pythagorean identity. So what we need to do now is we need to find the cosecant. Cosecant means r over y. So r over y. So you can write this one as simply r, radius over the y coordinate. So y coordinate is so radius is 3. So 3 over y coordinate is 2 square root 2. So that's the answer. Next, we're going to consider the general case where we have like not just a value, but like some expression like x or y as the values. In this problem, we're going to rewrite certain trigonometric expressions as algebraic expressions. For example, we can look at this problem. So what we're gonna do, we're gonna write sine tan inverse x as an algebraic expression. So we can rewrite this expression only using x. So so what we're gonna do, we're gonna use a similar argument. Since we know that tan inverse x is an angle, so we're gonna start the problem like this. So we're gonna say let theta equal a tan inverse x, because that's the angle. So we're going to pick that apart as a tan inverse x. So then we can see that then taking a tan on both sides, then tan theta equal x. And then we also know that by the definition of tan inverse, so we know that theta is in the interval negative pi over 2 to pi over 2. So that's very important. And also we know that x is going from negative infinity to positive infinity. So what we're going to do is now we're going to draw the triangle as we did before, and then we're going to find, in this case, sine theta, because since tan inverse x is theta, what we need is sine theta. But there's a problem now, because we don't know in what quadrant theta lies, because x can be positive or negative. So what we're going to do, we're going to consider two cases. So so we're going to consider the x positive case and x negative case. So tan theta x, this you can write as tan theta equal just x. So we can write x over 1. So that we're going to get another side. So now what we're going to do, we're going to consider two cases. So let's consider the x positive case. So if x positive, its angle is in the first quadrant, so then we can draw it like that. And then we, as before, we draw a perpendicular to the x-axis. And since this is x positive, so this is x positive case. So x positive case. So this is, if you consider this as theta, then you can see this is tan means opposite over adjacent, so it's x over 1. So you can see this is 1. So only thing what we need to do is to find the hypotenuse that we can find using the Pythagorean identity. So if you use the Pythagorean identity, and you can see that this is x squared plus 1 squared square root, so this is going to be 1 plus x squared square root. And then from this we can find sine theta very easily. So now, so that's one case. So that means, so now your problem going to be, so you can see that, so this is for x positive case. So we can see sine tan inverse x. So this simply becomes sine tan inverse x means theta, so it's sine theta. So that means according to this triangle, sine theta is simply opposite over hypotenuse. So this is x divided by 1 plus x squared square root. That's for x positive case. So what happens when x is negative? If x is negative, you can see that the angle is in the fourth quadrant. So if the angle is in the fourth quadrant for negative theta, so you can simply extend. So that's x negative case. So it's gonna go there. That means this is the new triangle. So new triangle is gonna be like that. So this is for the x negative case. So this is the x negative case. And then you can see that even in this case, hypotenuse is exactly the same. So that means if you look at the ratio, you can see that you get the same ratio. You get, so this is the angle theta now. So it is on the fourth quadrant. So you can see the ratio is still opposite, which is x over hypotenuse 1 plus x squared. That means you get the same ratio. So that means depending on whether x positive or x negative, you get the expression as a single expression x over 1 plus x squared, depending on whether x positive or negative. So it doesn't really matter, you get the same expression. So this is the answer for both x positive and x negative. So as the next problem we have write cotangent cosecant inverse alpha. So what you notice it where alpha is negative. So alpha negative means, so you can see that the angle that you get is in second quadrant as an algebraic expression. So we do the problem like as we did before. So we're gonna see so the answer. So let again inside. So that's the angle. So we're gonna say theta. So let theta equal cosine inverse alpha. And then you can see that since the alpha is negative, this angle has to be in the second quadrant. So where the theta is in the second quadrant. And so you notice that the alpha is negative now. And also it has to be bigger than -1, otherwise cosine is not defined here. Good. So this says that as before, cosine theta equal alpha. So alpha you can write as alpha over 1. Then you can get the hypotenuse. So we draw an angle in the second quadrant because you get a negative value. To get a negative value, because we know that this theta is always by the range of the inverse function. We know that the theta has to be in between 0 and pi. That's why this angle has to be in the second quadrant. Good. So that's the angle theta. And then as before, we drop the perpendicular, and then we use this idea. So cosine theta, cosine means adjacent over hypotenuse. So the adjacent is alpha, but alpha is negative, and then hypotenuse is 1. Now we can use these two ideas to find the other side. That's you can get square in the hypotenuse. This is 1 squared minus alpha squared square root. So it's going to be 1 minus alpha squared square root, and it's positive value. Now what we can do, we can use this one to find the cotangent value. So what we need is the cotangent. So what we need is cotangent cosine inverse alpha. So this is simply you can see not the cosine, cotangent. This is simply cotangent theta. So according to the triangle, so cotangent means adjacent over the opposite. So you can see the adjacent of opposite. So it is y over x. So that means, so we have alpha. So actually, yeah, this is a cotangent. So it's a cotangent means the adjacent opposite. So so it is x over y. So we need x over y. So x is alpha over y means 1 minus alpha squared square root. And you can see that the alpha carries a negative sign, and so you should get a cotangent negative, and it says that this is a negative one. So that's the answer for this problem. So the other type of problem we're gonna do as a special problem, because you can see that that's like a little difficult, has like a long argument there. So we can do as a special problem.